Okay, so hi everyone. I hope you're all doing good. We, SP University of Boomerda student chapter, are very honored to have with us today Mr. Ahmad Shammari, who's going to give us insights on basics of Pipesim multiphase fluid flow simulator. So, flow assurance and production optimization are critical or decisive parameters in the oil and gas industry. And as you know, various software options exist for modeling production system performance, aiding petroleum engineers in these studies. And PipSim stands out as the top multi-phase flow simulator from SLB. So yes, in this webinar, we'll explore its fundamental features, focusing on modeling production and injection system components via nodal analysis, artificial lift design, and optimizing surface pipeline networks. Sir, do you want to introduce yourself or do you want me to do it?
Go ahead, please.
Yeah, okay. So as I said, we have with us today Mr. Ahmad Shammari, who is a senior petroleum engineer with over 20 years of expertise in production engineering, flow assurance, and digital oilfield solutions. As the product champion for PipSim, a premier multi-phase flow simulator, his tenure at SLB since 2017 follows a prolific 15 years tenure at Saudi Aramco. At Aramco, he excelled as a technical consultant and project manager across diverse oil and gas design and optimization projects within production engineering. His contributions are underscored by 4 patents in well modeling and reservoir performance monitoring. So Ahmed earned his master's degree in petroleum engineering from KFUPM in Saudi Arabia. He's an author of several SPE papers and has actively engaged in various training courses, workshops, and webinars catering to academia and the oil and gas industry. So we have this man with us today. So without further delay, let's start. Guys, please, I would ask from you, during the conference, if you have any questions, write them in the chat box, and then we're gonna answer them in the end. So yes, please, let's start.
Okay, thank you very much. I'd like to appreciate the SPE section of University of Boumerdis student chapter. And I'm impressed really with the professionalism and the high level of good organizing skills. I mean, that really goes beyond actually the level of just normal students. So really appreciate that.
Thank you, sir.
Today, inshallah, we'll be talking about PipSim. And PipSim, as you may know, is a steady-state multi-phase flow simulator. When we say steady-state, we need to between PipSim as of software
Sir, I think some of us have an issue hearing your voice.
Okay.
No, we heard it, yes.
Okay, sorry for that. Let me just check if everything's fine here. Okay. Can you hear me clear now?
Yes, sir, we can hear you. Thank you.
Okay. So in the multi-phase flow simulation, wells and pipeline networks, we do have basically 2 classes. One is a steady state, which PipSim belongs to, and another one which is the transient flow simulation. In SLB, we have a software called Olga. The main difference between steady state flow simulation and transient flow simulation is the fact that in transient flow simulation, we have the concept of time, meaning we can, or the simulator can, predict the fluid behavior or fluid hydraulic parameters that are changing with time. So if there is, for example, slugging in the pipeline, Olga, software like Olga can capture or predict this slugging behavior, and you can even look into the pressure wave passing through time. Similarly, for example, if you have a well startup or well cleanup scenarios, in which the system is not in a steady state mode, basically pressure, temperature, phase behavior is changing with time, even if it's a short period of time, that's what we're talking about hours, then Olga, as a transient flow simulator, can predict that. Okay. PipSim, although it has the same, I would say, powerful engine in terms of flow modeling and PVT and equation of state, compositional modeling, and so on and so forth, it is used in steady state conditions, meaning you assume that the time, right? And if you want to see that, okay, I need to forecast, for example, what will be the production in 2 years, for example, where you need to have the time element. Basically, you need to provide the change in boundary conditions in the future, and then simulate that. Like, for example, you say, I'm assuming that every 2 months, for example, every 5 months, every 6 months, the reservoir pressure is going to decline by, for example, 50 psi. Then you put multiple pressure steps into the sensitivity, and then the simulator will tell you how much production, what will be the production performance under these different pressure steps. But the time itself is not an element as part of the steady-state simulators. And this applies to all similar steady-state simulators in the industry today. So PipSim has been in the industry for almost 40 years now. Started the development around 84. So actually next year we are going to celebrate the 40 years anniversary for actually both PipSim. PipSim was developed by a small company in the UK called Baker Jardine in the 80s. And until the year probably 2000, it was owned by this company, which is Baker Jardine, until Schlumberger at that time, SLB today, has acquired the software from that company. And then until then, it is being developed and improved over the years. PipSim also has gone through major upgrades. Whatever we're looking at right now is what we call the new generation or the next generation. Until 2012, 2013, there was a completely previous version of PipSim, and in our office, basically, we call it PipSim Classic because we don't support that anymore. So without further ado, this is the first screen that you will see when you open PipSim. Okay. PipSim has basically a space here called recent workspaces, which means that any project that you worked on will be listed here with its own directory. You can have two perspectives, well perspective and network perspective. So you can open an existing network or a new network, or you can create a new well perspective, or you open an existing well perspective. This space here is for the license information, depending on your company, how many licenses. So every license module, if it's active, then it becomes green. If it's either expired or completely consumed by other users in your company, then it will turn red. That means you cannot use that until it is green. We also have the open. So if you have, this will take you to basically the PipSim directory, and you can also, this will help you navigate through the file locations into your machine. And we have the help. The help here, I recommend everyone to, if you want to learn PipSim really, you can use the help. The help is very useful, very powerful. As a matter of fact, there are, I think, 7 or 8 tutorials that are available with a step-by-step guide in which you can follow, you can, read and enter the data, and then it will lead you until the results. So if I click on the PipSim help button here, then it will open the help. And if you go to the content, there are 3 tabs here. If you go to the content, you can go to the last thing and it says tutorials. Then under these tutorials, there is a good number of, as it says, tutorials in which you can actually follow to build model with data, and it will drive you through nice pictures until you actually reach to the results. Okay, so we have oil well performance, gas well performance, subsea tieback design, looped gas network, okay, something like this. And then you have also the gas lift optimization study, and so on and so forth. So today I'm not going to of course follow these step by step. We're just going to have a general overview about the software, and hopefully if we can arrange maybe future sessions, we can together go into some of these tutorials and build cases based on the data that are available in these tutorials. Okay, so again, we have the help. So under the help, we have also the support hub. There is a PipSim webpage that will take you to SLB PipSim webpage, in which basically you go here, and then here you can read the latest information about the software. There is a little bit old presentation here that I did about network optimization back in, I think, 2019. And then you see the latest feature. Okay, so if you go, for example, you click here to the 2023 new features, you see whatever we have added recently into 2023. This is 2022, and so on and so forth. Okay, so this is the website that you can see here under the help. There is also videos. I think this channel has changed recently. No, it's available. So there are also official videos if you want to follow. These videos are not, of course, done by me. It was done before my time even. I mean, it says 3 years. It's actually more than 3 years. But this is, like, for example, this one is done 7 years ago. Okay, so there are good videos, short videos here, not very, I would say, detailed, but give you an overview. And also we have the case studies. So the case studies are available with a lot of ready-made examples that you can use to have an understanding about the software with different options, right? And you can send us an email. So what I will do right now, and we'll have the options. The options is a little bit advanced. I will not probably go into that, but what we're going to do right now is that we are going to basically go into the backspace, and then we will have now. So as you can see here, this is the main, I would say, landing tab, right? This is the main tab. So now what we're going to do is that we are going to start with looking into an existing network. Okay, I'm gonna open an example. This example will open a network. So I'm going to open a network example. This network includes wells, and then from there we are going to navigate through the different options. So what I'm going to do right now, I'm going to go to case studies, and then you will see under case studies we have different folders. One of them is fluid files, network models, pipeline models, Python toolkits, training exercises, tutorial examples, and well models. These tutorial examples are the same that we have in the help. So if you want to compare your basically model that you have created by following the tutorials, the tutorials are already built and they're available here. Okay, so now I'm going to open a network model. When I open this network model, I will start by looking into a GIS network model. So what do we mean by GIS? So GIS stands for Geographic Information Systems, okay? Let's have a look. What do we mean by a gas gathering GIS? So when I click on that, click on open, then you will see PipSim with a network, a field that is built on top of actual geographic or actual map, okay? So let me expand this now. Probably bring this one to the other side. Now, as you can see here, there is the map, right? So if I zoom out, just to have an idea, where is this field? Zoom out more and more. I will see that this field is actually Central America, right? So this is in the United States. So I'm going to zoom in again a little bit more until I reach to the network. Now I'm here. Okay. So now we see that we have numbers here. Okay. These numbers represent what is called the cluster mode. So if I go to the format, you'll see here that I have a checkpoint called cluster. Uncheck that, and then you will see that the equipment are now shown. To see the the network more clearly, I can change the base map. Like for example, I can go to the base map and I select, for example, the light mode. And now I can look into my network, so I can zoom in. And you will notice that this is a well. This is another well, right? This is a choke, okay? Now, if I want to navigate into my map, I need to click the control button. So I click the control button on my keyboard, and then I can move. The reason we're doing that is because in the mouse, left mouse, it is used to select the components, right? That's why in order for you to navigate into the GIS map, you need to hit the control button, and then you can move out the whole network. So as you can see here, we have here a separator, okay? And then this separator has a water line. There's a pump here, and then there is a water injection here. We have a line for the gas. We call it, no, sorry, this is for the condensate, which is basically the oil that comes out of the gas field. And then we have the gas line, which goes to a compressor, a heat exchanger, and then an export line, which goes to the sink, okay? So now, each of these black lines are actually pipelines, okay? So if we go and then bring the base map again, you will see now that are actually built based on the actual locations of the flow lines. And PipSim has the ability to capture the length and the pipeline elevation profile from the GIS map itself. One of the things that people don't know is that when you go to Google Maps, for example, or any basically geographic information systems, we don't only the map doesn't only have the 2D shape. It also you have the information of the 3D, meaning at any point, if I click my mouse, any point over this GIS map, the GIS. So now what PipSim does is that when you build your pipeline along this path, it will be able to capture its elevation profile automatically, okay? If I double click on this pipeline, for example, you will see that the pipeline profile has been captured. So This feature is unique in PipSim. You will not find any other software that can do this, that can capture the pipeline elevation profiles automatically from the GIS, okay? And not only this, I can even play with the accuracy, or the not only the accuracy, but the refinement, or basically the accuracy, the length of each of these segments where the pipeline elevation is captured, okay? The way we do that is basically, if I go here, you'll notice here, for example, that for this pipeline, we have a step every 30 feet, right? So now, and this is the interval. It says the interval is 300 feet. So now what I will do is that I'm gonna make the interval as 100 feet. And then I'm going to increase the maximum point to become, let's say, 200. As you can see here now, all the pipelines turned into red, because now it will allow me to recapture the pipeline profiles again using the new intervals or the new GIS configuration. So there's a button here that says capture elevation. Okay. So when I click on that, what will happen is PipSim will send this. One thing that I want to show you is let me just show you here. There is something called GIS nodes. These GIS nodes are basically added when I start adding or building my pipeline. I will show you that in a moment. But what will happen is, in addition to those GIS nodes, so each of these GIS nodes, PipSim will be able to capture its elevation and length. And on top of that, it will add to it the interval points, which is, so that you will see that once I click capture elevation, so every 100 feet, there will be a point in addition to those GIS nodes, okay? So let me do that. So when I click on, I'll double click again here. You'll see that we have nothing, okay? And now we have only, 30 points. So now we see, when I clicked on 100, it divided my steps now, divided my segments into every 100 there will be, and then these are the GIS nodes. So this is a GIS node, this is another GIS node along this horizontal, distance, and it also found the latitude and the longitude, which is its GIS location in the universe. Okay, so now the only thing that is missing is the measured distance, and which is the length and the elevation. Why the horizontal distance is not the same as the measured distance? Because of the elevation. So the horizontal distance is, if I bring just a measurement tool to measure this distance here, this is basically based on the 2D location. However, if there's an elevation going up and down, the actual length will be more than the 2D length, right? So that's why when I click on capture elevation, this is what will happen now. So you see, now PipSim was able to capture the length of each of the sections or segments, and you will see that, for example, at the end, this is the measured distance and this is the elevation as it is captured from the GIS service, and it's done that for all the pipelines automatically. Okay, why this is important? Because the angle of the flow is actually used in the flow model to determine the flow regime, to determine the velocity of each phase, and eventually to accurately predict the pressure drop. So as you can see here, this is the pipeline profile. Okay, I did not enter any data. All that was done automatically. Okay, so now let me uncheck the GIS nodes and let me add a new flow line, manually using my hand, right? So now let's assume that there is a well which is located, for example, here. You see, I can see that on the GIS map, there is a well here, and this is the actual flow line topography or flow line path along my map, okay? However, I need to connect it here into this pipeline. So now, along this pipeline, there is no junction. So the way we connect pipelines and PipSim is that you will need a junction. So what we are going to do, we are going to go to the Insert tab, and then there is an option here that says Split Flow Line. And the tooltip reads, this action will split the flow line into two separate flow lines with equivalent properties separated by a junction. So now I will be able to separate my flow line at this point here in order for it to have a junction, so that I can add the new flow line that I'm going to add to my network. So let's do that. So click on Split Flow Line, and then I'm going to go here, click, and now automatically, of course, it turned red because now it needs to capture the elevation again. And it also added a junction here, okay? Now, what I'm going to do now is that I'm going to add a source. I'm not going to add a well now because let's talk about wells later on. I'm going to add a source, and I will put it here. What's the difference between the source and the well? The source is basically a surface boundary condition, meaning you can specify the pressure at the boundary condition at the surface, or you specify the flow rate. So you can say, I am injecting, let's say, this amount of flow rate, and solve for the pressure, or I can tell them, okay, this is the pressure, solve for the flow rate. But in order for it to be able to solve, I will need to specify two things. I need to specify the fluid that is connected to the source, and I need to specify also the temperature. So when I double click on the source, okay, it needs a fluid. So let me just select any of these fluids here, say alpha. The temperature is, for example, 100 degrees Fahrenheit. Okay. Now I've added my source. It is still red because it's not connected to anything. Now I'm going to add a flow line by following this GIS map or the path or the flow line on the GIS map. So I will go to the flow line. There's a flow line button here. So when I hover off this flow line, it reads surface pipe used to convey fluids in horizontal or inclined flow. And the flow line is different from the connector because the connector has no pressure drop. It's not a physical pipe. It's just to connect objects together. Like, for example, I can connect this source to a choke, and it's exactly on the same location. And there is no pressure drop between this source and the choke, right? So now I'm going to add a flow line. So the moment I click on the flow line button and I move my cursor inside the GIS map, immediately when I get closer to an object that can be connected, it will have a green line. And then I will click. And now you see here, the flow lines start to be connected. And now the moment I start clicking on the map, it will add a GIS node. Like, for example, I'm going to add a GIS node here, another GIS node here, and then I start clicking until I reach my junction. So when I double click on this flow line, I will see that automatically it created for me a step every 100 feet, because in my format, I said I need 100 feet interval. And then it also created junctions or nodes based on my GIS clicks, okay? So, and along each of these intervals, there is latitude and longitude, which is, again, the location, the universal location of these nodes with respect to the map. Now I need to enter the diameter. Let's say the inside diameter is 4 inches. And now I can click on capture elevation. And now automatically the length and the elevation profile. With that, I can now zoom out. And so far, we have not seen the data related to the wells. I'm just talking about the network perspective. And network simulation will look like, what it will do, okay? So you will notice that I have now wells. These are the wells that are available in my canvas. So we have wells, we have sources, we have connections, including flow lines, we have junctions, we have equipment, chokes, see? A compressor, heat exchanger, a pump, a separator, and then we have the fluids, okay? Now, let's have a look into one of the wells just to have an understanding about the boundary conditions that's going to be feeding into my network. So for example, if I start with this well here, okay, double click on the well will open all the well information. One of the things that we know about, other software is that in other software, if you want to model wells, you need to open a completely other software, meaning you cannot have the same interface for modeling the wells and the network. You will need to have a separate software for wells and another software for the network. Unlike PipSim. In PipSim, it's everything in one integrated model, which has a very good advantage because now you don't really, the file management will be simple because you don't have so many models for each well. And then integration between companies is much better because now you can just send or share one model. This model includes really everything, includes the fluids, includes the wells and the network, okay, in the same model. And not only that, if you are a production engineer who is only focusing on wells, you can simply, by click of a button, change the perspective. Like for example, here, if you go to the home tab, there is a perspective on the left, N, that stands for network, but then you can switch that to W, which is well, and the interface of the software will change completely. And then your model becomes well-centric. You just will focus on wells. And although your model includes several wells, but now you can focus on one well, you can easily navigate to another well by this drop down or by simply clicking like the. So now your model becomes like a container, like a folder that includes all the well data, right? And then you as an engineer, you can. This is very important for, as I said, model management, for the ability to share data with your colleagues and not lose data, because one of the challenges if you have a different software to model wells is that your network will not be in sync. Because for example, you have a network model that's composed of, let's say, 100 wells, right? And then there are certain engineers who are working on, let's say, certain wells. They can update the wells there, okay, and in their folder, and they can add, calibrate the well, or change the GOR, or change the productivity index. Now, each time you need to run the network, you will need to re-import the data from the wells to the ELP curves again to the network in order to run the network model. And this is the beauty of PipSim. Everything is in one folder, integrated. Whenever something changes, it will change the network behavior immediately, okay? So this is the network perspective, the well perspective. I'm going back to the well perspective, okay? Now, if I'm in the well perspective, when I double click on one of the wells, okay, I will see that the well data will come with its all details. Okay, I can have a look into the deviation survey. I can have a look into the heat transfer, the tubular, all the detail. We're going to talk about the wells in a moment. The completion, you can look into the reservoir pressure. You can look into the temperature, whatever completions you have. We're using Darcy here, for example, okay? And also the surface equipment for this flow line, because as you can see here, this flow line is what? This flow line is this one, okay? It's exactly the same one. So look into this deviation survey. And now if I double click on this deviation survey, it's the same, basically. So this is the same flow line, okay? The scale is just a little bit different. This is the same flow line, okay? When I view it from the network perspective, if I double click on the well perspective, it will show me the well with its surface equipment, okay? Now, when you are on the well, if you don't want to switch to the network, to the well perspective, you can actually run your simulations while you are on the well alone, while you are in the network perspective. And all the tasks are actually activated here. So you can run nodal analysis for this well, right? While you are still on the network perspective. You can do sensitivities. You can change whatever you want, right? While you are in the network perspective. So it really depends on your choice, which perspective you'd like to work on, okay? Again, I'm not gonna spend a lot of time on wells right now because I will have time on it, but just to let you know that when the network simulation is solved, it is actually solved starting from the completion of each well. So it will solve the entire network starting from the reservoir pressure of each of the wells. And then it will calculate the pressure drop using the IPR method, the pressure drop across the completion, the drawdown, using the IPR method. And then it will calculate the pressure drop across the tubing. It will have, for example, if you have any artificial lift equipment or something, all that will be taken into consideration until it reaches the surface. We are in PipSim, we do not use lift curves or VLP curves to solve for the pressure drop in the wells. Everything is solved in one integrated set of equations, which will increase the accuracy, right? One of the challenges when you have, let's say, wells are modeled in a different software, you bring it to the network model, you will need to create VLP curves, okay, or outflow curves. If you're not careful about how to set up the ranges of these VLP curves, then there will be a problem in the accuracy, okay? So now what we're going to do is I'm going to run the network simulation. So click on network simulation. And now the first thing the software will do is that it will go into all the wells, all the sources, and then it will bring the boundary conditions. What do we mean by boundary conditions? Basically, in this case, it is the reservoir pressures, okay? And now there are certain, in a certain sources, you can specify either the rate, solve for the pressure, or specify the pressure to solve for the rate. You cannot specify both, okay? So now in this case, we're still missing this source. This source doesn't have, any of these. So this is the source that I added recently. So let's assume that I'm going to say that, okay, the source now, the pressure, downstream, the choke or everything, the pressure boundary for this source is, for example, 300 or 400 PSI. Now we also have the two sinks. One is the condensate tank. One is the gas sales. We also have this water injection well. The separator here will separate the water. We'll take the water from the separator. It will send it into a surface pump. The surface pump has, a power of 112 horsepower with an efficiency of 80. And I can specify myself the pressure differential if I want, how much I'm adding into the fluid, and then it will be injected into this well. So this is a water injection well, okay? When I double click on it, you will see that the flow direction is downwards, and then this is the completion. So this is a water injection well. Okay. Now I'm going to, you know, when I specify this, also, okay, do I have anything missing? Okay. Let me just run again. Am I missing something here? Why cannot run? So we have this one. Yeah, because this is a source, I need to enter the temperature. So reset boundary conditions. Okay. Okay, specify the pressure rate to be 400. And now we are ready, we can solve. Okay. So now I run. Now it's going to start from the wells with all of its fluids, all the tubing details. If there is any artificial lift, then it will on the pressure boundary conditions, the fluids, the deliverability of each of the wells, right? Until it will simulate how much each well is producing. And it will calculate literally all the fluid parameters, pressures, temperatures, velocities, corrosion rates, for example, along the flow lines. And then it will tell you how much is the total pressure, how much is the total flow rate at each of the sinks, okay? As you can see here, there are some sources where we specify the rate, and another source where we specify the pressure, okay? Now the simulation is done, okay? And one way of looking into the data is, of course, we can navigate through the node branch results, or we can go to the, we can go to the format results gradient. So the results gradient here will give you a good distribution, color-coded distribution of all the parameters. Like, for example, here I'm looking into the pressure distribution. I can look into, for example, the, let's say the corrosion rate, okay? This is the corrosion rate. I can look into the, let's say the flowing oil flow rate, okay? Along all the five pipelines. I can look into the hold up fraction, for example, erosional velocity ratio, for example. See, this is erosional velocity ratio, in which if I reach 1 or more, then there is a tendency for erosion. Okay, all that can be visualized using color coding, right? Or, as I said, I can go to the network simulation, and then I can look into the results using node branch results, where I can filter. I can say, okay, show me the wells only. So now for these wells, we can look into how much is the gas rate, how much is the water cut, how much is the standard, this is flowing, how much is the stock tank gas flow rate, the GOR, the liquid rate, and so on and so forth. So this is using the nodes, basically each well. I can look into the branches themselves, even the branches that are the internal branches. Or I can go to the profile results. The profile results will show me, you know, I can select all the wells, for example, and then I can plot the profile results with any parameter that I'd like to see. Like, for example, I can click on show plots, and now it's plotting for me the pressure distribution. So I can select literally all the wells if I want. So this is the pressure, this is the total distance, okay? I can flip that, I can add, for example, the temperature, okay? And so on and so forth. So there are a lot of ways to actually simulate the results, okay? So this is a a production network. All right. Now, I can also, there is also another perspective. Like, for example, if this network, GIS network is actually difficult to see, you can easily switch to the network schematic. So the network schematic will have exactly the same capability, right? You can, as a matter of fact, you can look into the results. So this is exactly the same network, but in a a schematic that is not that doesn't, like, for example, I can choose move this well location and so on. It doesn't affect the length. Whereas in the GIS, the moment I move any object, then the pipeline length will be different. Okay. Here we can also look into the annotation of the results. Like for example, we can see that it is showing us the pressure. I can select the so this is the sink gas rate. I can put the let's say source gas flow rate. Okay, so it's showing me the source gas flow rate here. I can look into, I mean, a lot of the I can look into the wellhead temperature. I can look into the wellhead liquid flow rate, for example, and so on and so forth. So this way also, this is another way of visualizing the results. So as you can see here, PipSim has a lot of ways to visualize your results so that you can represent your case. If you want to create a new project, you need to validate some study. You can have a budgetary estimate based on the simulation. All that can be done using different results viewers. Okay, so this is one network, one production network that we have demonstrated. Let us see if we have questions so far. For offshore cases, does it also capture the elevation profiles? Yes, it does, but not as accurate and as let's say small segments as the onshore, because in onshore we have the GIS data is more detailed, I would say, but still the offshore is also possible. Okay, now let me show you some other examples. So if there are no questions on this network, we can move on into other examples. So what I'm going to do right now, I'm going to show you other case study in which we have pipeline models. Okay, so this is a pipeline model. All these pipeline models are actually based on SPA papers. Okay, this is an offshore pipeline. Okay, and as you can see here, this is the platform. When I double click on this flow line, okay, it will show you the pipeline profile. Okay, and we have actually I think we're using let me see here, we're using let me see, let's regenerate the pipeline. Let's put 50, for example, here, and then okay, make maximum number of points of is 500. Okay, and now when I click on, so now it's recalculating now the points. Okay, now populate from GIS data. Now I click on capture elevation. So this is, as you can see here, it's not that accurate. Okay, and there are also different sources depending on the data source, depending on the GIS data source. The pipeline profiles will be generated, and also we have the other pipeline profile here, which is on land. You will see that it is actually more accurate. Okay, so this is a pipeline that starts with a source and a sink, no wells. Okay, and in this network we're using compositional fluid. we'll talk about composition, probably the fluid types later on. Okay. Now, enough talking about the network. Let's go to the wells. Okay. I'm not sure how much time we have. We're almost finished 1 hour. So probably we'll take maybe 20 minutes talking about wells. Okay. So now, under the workspace, I need to go to new and then new well. Okay. So now I will create a new well model from scratch. Okay. So no. Now, I will show you that we can really build a well model quite quickly. Okay. Building the well model can start by identifying a fluid. Okay. I mean, you can either way, you can make the fluid at the end, but we can start with the fluid. Like, for example, for the fluid, we have different fluid types. We have black oil. We have compositional, in which you define an equation of state, the composition, or you can import a PVT file from maybe PVTSim or any other PVT package, or a multi-flash file. The multi-flash file, basically in PipSim, when you buy PipSim, it comes with a PVT package from KBC, a third-party company. They have a strong PVT package called multi-flash. So you can use that to create an MFL file, which is a multi-flash file. Then you can import it to PipSim here. Okay. Let's start with the black oil. So when I double-click on the black oil, now I can create a new fluid. I click plus. And then there are some templates. We can start with light oil and gas. Click OK. And now I need to just define the gas oil ratio. Let's say the gas oil ratio is 400 and the water cut is 0. Okay, sorry. And the water cut is 0. What are the other parameters? Double click here. And then we will see that we have, this is the water specific gravity. This is the water salinity, and this is the API. The API is basically the water, the oil density. Let's put for example, an API of 32, and the gas specific gravity is 0.8, and no contaminations, no impurities. There are, of course, ways to enter the viscosity, the emulsions. You can calibrate the fluid using measured data, but I will just use the default right now. So when I click on OK, now I have added a fluid to my project, but I have not added it to any completion. So now we're done. We have added the fluid. Now let's simply build a well model using drag and drop. So I'm going to drag and drop a casing. Okay. By default, this casing go to 10,000, and this is the inside diameter, 4.7. Okay. Let's make this casing a little bit, bigger. So it goes to 6,000. So the inside diameter 6 inches. And then the maximum measured depth is, for example, 7,000. So all I did right now is I added a casing. Then we are going to we can add a tubing, or we can add the completion right away. So I can add a completion here. I can put it at any depth that basically based on the reality. Now this is the completion. The completion, I can enter the reservoir pressure. Let's say the reservoir pressure is maybe 3,000 PSI. Sorry, I'm using field units. So if you're not familiar with the field units, you can, of course, use your own units. Reservoir temperature, let's say 200 Fahrenheit. Productivity index is maybe 5, right? A barrel per day per PSI. And now the fluid that I have added. So my completion is ready. This is my IPR. And as you can see here, this is enough. I mean, I can run my model now because I have a completion, I have a casing. But, of course, we need to add a tubing. So let's drag and drop a tubing here. This tubing, now you see the casing was added already. This tubing will go all the way up to 6,800. Sorry, let's make it, because this is now below the completion. So now let's make it 6,500. Okay. And now PipSim is telling me that, okay, now I have two flow paths. I have the tubing and I have the annulus. That's why I have green lines here. Then we need to add a packer to define the flow path. So I have added a packer. Now only the flow path goes into the tubing, right? So now the tubing, the default is 2 inches. So let's make it a little bit bigger. So let's put, for example, 3 inches. Okay. And now that's it. I can simply run my nodal analysis. So I simply added a casing, a fluid, a completion with a fluid tubing. Of course, if I need to add more details, I can do that. I can go to the downhole equipment where I can add, for example, subsurface safety valve. I can add, you know, a downhole choke, whatever, right? The heat transfer by default is, we specify the heat transfer coefficient, which is 2 by default, and the soil temperature is 60, right? If I want to have it more details, of course, I can go to calculate the heat transfer coefficient. And now I can specify now the ground conductivity, etc. Or I can simply use that and then change it if I want. So that's it. Let's run our first model. So when we're done, if I go to the Home tab, I will see that I have all these tasks that I can run for the model. The most famous one is, of course, the nodal analysis. The nodal analysis is a task that will create two curves. One curve representing the inflow, which is how much is the pressure drop at the bottom hole pressure by injecting different rates. So this is, it's basically a flow and bottom hole pressure on the y-axis, flow rate on the x-axis, and then it will, based on the PI that I have entered, the fluid and the pressure, it will construct the inflow curve. The outflow curve is also at the bottom hole pressure. How much is the pressure needed to push the fluids into the wellbore? Okay. Once there is intersection between the inflow and the outflow, then this is the operating condition. So this is the simple term, what nodal analysis is. So when I click on nodal analysis, it will ask me, where do you want to put the nodal analysis, the bottom hole or the well? And I tell them, okay, the bottom hole. So it immediately created now my nodal analysis point here. I need to identify my outlet pressure. In this case, my outlet pressure is the wellhead pressure because I did not enter any surface flow line. So if I say the outlet pressure is 300 psi, and now that's it. I can now click run. And voila, we're done. This is our inflow line. This is our outflow line. And this is the intersection. Based on these conditions, the well should produce 4,700. Okay? As simple as that. Now, let's make the situation more difficult. Okay? So now, instead of zero water cut, let us see if what will happen if the water cut becomes 80%. So I go to the completion and I tell him fluid data, override method. I will override the phase ratio and I'm going to enter water cut of 80. Now, if I run the nodal analysis, I will see that the production must be less. Why? Because the VLP start going up. The fluid becomes heavier. So the VLP will go up. So I go to the nodal analysis again. Exactly the same conditions. I click on run. And you will see that now we're producing less than 1,000. The well is almost dead, by the way. It's now intersecting in almost in the unstable region. See? So this is what we call the unstable region because it's intersecting between the intersection between inflow and the outflow happening on the left-hand side of the VLP curve, right? So now you will notice that if I simply increase the outlet pressure by maybe 50 psi, I'm assuming that the well would be dead. So there's no intersection between the inflow and outflow. See, well is dead now. It says unconverged, there is no solution. So what do we do? we can either, so there are different scenarios. We can either make a water shutoff. Water shutoff meaning we can work on the completion by plugging the completion that's producing water and then producing in an area which is a bit dry, still dry. Or I can install an artificial lift, okay? One of the ways of doing the artificial lift is simply by going into the ESP design, okay? So I can design an ESP and if I want to exactly increase the production into a certain rate. So I go to the ESP design. And now, first thing it will do, it will bring the boundary conditions. And then it will tell you, okay, what is the required wellhead pressure? So I say, okay, the same wellhead pressure was 350, but then it will ask you, okay, how much do you want to produce? Then I look into my inflow and outline and say, you know what, let's bring this VLP, let's make it intersect at 4,000, for example, okay? Which means that I need to bring this red line, red curve, down so that the intersection becomes at 4,000. And all that is going to be done by the calculating the ESP. So if I tell them I need the design production rate is at 4,000, enter. Now it created this line. And then once I click this, catalog, it will open for me, it will find for me all the pumps that are suitable of producing 4,000. Click on that. And now it's finding the pumps, and then it will list them based on its efficiency. Based on their efficiency. So each the pump with the highest efficiency will become at the top. So this is our highest efficiency pump. It's a radar pump. This is the model. This is the series. And then these are the conditions. Now, I still don't know how many stages do I need, because this is now the pump that is suitable for this flow rate. But how many stages will depend on the pressures. So when I click on OK, it added the pump, but then I need to click run in order for it to calculate how many stages are needed based on this frequency. So I click on run. So running now is not actually running the well performance itself. It is running the well performance with calculating the pumps to calculate how many stages needed for this pump to produce 4,000. So when I click on run, this is what it's going to do. So now immediately it says you will need 57 stages under this speed. And now this is the power. This is the efficiency. This is the head added by the pump. This is the differential pressure across the pump. And now if we go to the actual pump performance, so this is the head added. This is the head curve. This is the current flowing conditions, the blue line. Okay. And now as you can see, it's on its best efficiency. The well nodal analysis is this much, as you can see here. So this is the intersection at 4,000. If I'm happy with my design, I simply click on install ESP. When I click on install ESP, this pump with all its number of stages is going to be added at the bottom of the tubing. Click on close. And now if we go to our well and run our nodal analysis with this ESP installed, of course, I'm expecting that the stock tank barrel or the production will happen, the intersection between the inflow and the outflow will happen at 4,000, stock tank barrel per day. Okay, so I go to nodal analysis now with the pump installed using the same outlet pressure, click on run, and then we're going to get the new IPR curve. Okay, as you can see here, where it's producing around almost exactly at 4,000 stock tank barrel. But now, just to show you one thing, if I want to see the difference between the effect of the pump, so I go to radar, which is the ESP that I selected, and then let me just put two sensitivities. for the operating frequency. So 0 represents the pump is off. 60 represents the pump is on, of course. And then when I click on run, I will see two curves for the outflow now. One curve with 0 frequency and another curve with the pump installed. Okay, and this represents the new operating conditions with the pump running. Okay. You know, guys, if I want to speak about PipSim, it will take a long time, but I think when we have passed the hour, I'll probably stop here. Maybe you can arrange other sessions in the future, and probably if you're interested, you can type into the chat if there's anything that you'd like to learn specifically about PipSim, so that maybe we can arrange other sessions in the future. Okay. It appears that we have some questions on the chat, so let's have a look into these questions. Can we add manually additional models of ESP that are not listed in the database? The answer is of course. You can do that simply by going to the catalogs here, this button, and then you go to the ESP catalog, and then there's a new button. You can click on new, and then you can add your own manufacturer, model, series, and then you need you can put the pump curve for the pump curve as a table, and then it will be converted into a performance curve. So the answer is of course yes. Another question. Thank you. Okay, is PipSim able to simulate and integrate geothermal production, or it will be available in the near future? As a matter of fact, in the coming release, which is 2024, which is coming probably in 3 weeks, we have added a new case. It's called geothermal well. So since I'm using the 2024 right now, let me just show you that example. So I go to help, case studies, and then if I go to well models, you will see that there is case number 115. It's called geothermal well. Click on opening that well, and then you will see a very good explanation. So this well actually is based on an actual SPE paper. These are the references. Okay, so this is an actual well called Mesa 61 in California, and it's basically producing steam. Of course, it produces at the inlet conditions, it's water, and then because of the high pressure, and then it starts flashing somewhere, and then once it reaches the surface, it is actually steam. Let me just show you. If I run PT profile, I click run, then you will see how much steam we have in the surface by modeling this well. Okay. So it's of course taking a bit longer time because we're using some advanced calculations for the flash calculation, for steam flash calculation. That's why if you go to the simulation settings here, this is what's recommended. You go to the advanced, you see that we have the compositional flashing options, temperature, energy balance, and physical properties are hybrid. And we're using single component for the pH flash calculation. It's a bit advanced calculation. But now once this is done, it will basically, now it's done, as you can see here. If I go to the show grid for this well, I will be able to see as you can see, this is liquid hold up. So this is the completion going up. So when we go down, we actually go up, and then a certain depth, we start having steam because the pressure becomes less. Then the steam will come out of the and then as you can see here, when you reach the surface, it's almost 4%, which means that we have now steam produced at the surface using this well. So this is an example that we have added recently. It's going to be already available in 2024 release, which is due in December. Okay, so the answer is yes, we can model geothermal producer well. Okay, in the future session, appreciate if we can talk about fluids, PVT equation of states. Okay, sure, we can do that. How do you view the tutorial videos for PipSim? It's available on okay, if you go to YouTube, all of these are on YouTube. So if I go to here, if you go to the help, and then you say go to videos, it will immediately open our YouTube channel. This is just a YouTube, okay? So this is, for example, automated network model building. So where is it? Well, they have changed the, let me see. Is it this one? No, not this one. Okay. We see here. Pipesim network optimizer. So this is an network optimization. This is perforation design. This is the nodal analysis. So this is a nodal analysis video. Okay, just a second. This is exactly following the same tutorial that I've shown you right now. This is, by the way, using an older version. As you can see, it's a bit 7 years old, but there's not much difference. So this is a YouTube video with voice, of course.
And enter a reservoir pressure.
I'm not sure if you can listen.
5,000 psia.
But you can follow that, right? So as I said, it's already available. And also you can follow. I have other videos as well. I have presented many PipSim workshops that you can follow if you're interested. Okay. Okay. Can you touch a bit on available VLP correlations in the software? Sure. So if you go to the simulation settings, you will find that there are different sources for the correlations. Baker Jardine is the company that was acquired by SLB in the past. We have so under that we have the famous ones: Ansari, Biggs and Brell, Dunson Ross, Hagdon Brown, Mukherjee Brell, and so on and so forth. Okay, these are all the famous flow correlations. But what we recommend is actually Olga S. So if you go to Olga S, you will be able to find the Olga S flow model, which is the most accurate flow model in the industry today. And this is not because I'm not saying that because this is SLB. I'm just saying that because of the fact it is proven that Olga S flow model is the most accurate. Of course, it's purchased and doesn't come by default with PipSim. It's purchased separately, but it is actually. And the release 2024, which is coming in December, include the latest Olga S flow model, which is 2023. Okay. Yeah, I have this. Also, we have Tulsa point model. Okay, the old one. We have Leda also. It's from Kongsberg, but this, of course, purchased separately. And we have the Tulsa. Anyway, so as you can see here, Neotech, I think we have also other flow models: Gregory, Aziz Govier, Gomez, and so on and so forth. Okay, so I mean everything is available. Can PipSim handle asphaltene? Does it include asphaltenes as additional phase, or it just tells you the risk at PT to have asphaltene? Yes, it just it can tell you the risk. So the way in order for you to do that, you will need to load a PVT file from Multiflash that includes asphaltene. Okay, so basically, let me do that. So if I go to MFL file, okay, I click. We already have some examples shipped with PipSim. So if you go to the case studies and then fluid files, you see the second one is asphaltene. So this is a PVT MFL file. MFL stands for Multiflash. So it was created using Multiflash PVT package. And then I can bring that into PipSim, click on OK. When I double click here, you will see this is the asphaltene envelope. Okay, so if your PT profile will go inside this envelope, then you have the risk of having asphaltene. We cannot model the formation of asphaltene or what's the thickness of asphaltene and so on. But if you'd like to avoid going into this asphaltene envelope, okay? Yeah, I guess that's it of the questions. So thank you so much. It's been a pleasure. So back to you, Yahya.
Yeah, so thank you, sir, for this delightful presentation. I think seeing the comments, we all agree on it. And, you know, as a production engineering student, it was very interesting to apply the theoretical informations I have and to see them being used within a software. So, you know, and to explore the large panel of, you know, possibilities that it offers. So, yeah, thank you, sir. And we would be very honored to have you with us for more sessions in the future. And
Okay, sure.
thank you, everyone, for being with us and assisting this lecture. And I also hope to see you with us in the future lectures and events.
Okay, guys, let's connect on LinkedIn, huh? You
Yeah,
as students, you need to make LinkedIn profiles and start connecting with professionals, okay? This is my advice to you.
Yeah, thank you, sir. And
Thank
I
you.
think we're gonna close this lecture, and I wish you all a good day. Thank you, sir.
Thank you very much. Appreciate it. Bye.